Namaste and welcome back to JEE Physics with Typical Monk. This is class 22, Electromagnetic Waves. Faraday showed that a changing magnetic field makes an electric one. Maxwell found the mirror image. A changing electric field makes a magnetic one and added the one missing piece, the displacement current. Suddenly, his four equations sang, a wave of electric and magnetic fields weaving each other into existence, racing at exactly the speed of light. Light was electromagnetism. Today, the displacement current, Maxwell's equations, the nature of these waves, and the spectrum they form. One idea at a time. Here is what you will master today. First, the displacement current and the Ampere-Maxwell law. Second, Maxwell's equations and how electromagnetic waves arise. Third, the nature of these waves, transverse, with E perpendicular to B perpendicular to C. Fourth, the speed, energy, and momentum of these waves. And fifth, the electromagnetic spectrum, plus the drills. One idea at a time. 4 ideas. Run this entire chapter. Look at them together first. Displacement current. A changing electric field acts like a current, completing Ampere's law. Maxwell's equations. 4 equations that unite electricity, magnetism, and light into a single theory. The electromagnetic wave. Mutually perpendicular oscillating electric and magnetic fields traveling together through space. Master line. A changing E makes B and a changing B makes E. Together, they fly as light. Now look at the picture. The structure of an electromagnetic wave. Transverse. The electric field E and the magnetic field B both oscillate perpendicular to the direction of travel and perpendicular to each other. In phase, E and B reach their maxima and their zeros together at every point along the wave. The trio E, B, and the velocity c form a right-handed set. E cross B points along the direction C. No medium needed. Electromagnetic waves travel through empty vacuum. That is how sunlight reaches us across space. Now what the wave carries. The speed, c equals 1 over the square root of mu naught epsilon naught, which is about 3 times 10 to the 8 meters per second, and in a medium, v equals 1 over the root of mu epsilon. The field ratio. The amplitudes obey E naught equals c times b naught. So E is numerically c times larger than b. Energy. The wave carries energy, shared equally between the electric and the magnetic fields. Momentum. It also carries momentum and exerts a radiation pressure on whatever surface it strikes. Now the missing piece that started it all. The gap. Ampere's law failed for a charging capacitor. No conduction current actually flows between the plates. Maxwell's fix. A changing electric flux acts as a displacement current. The displacement current equals epsilon naught times d phi E by dt. The full law. The Ampere-Maxwell law adds this term so the magnetic field stays continuous everywhere. The 4 equations. Gauss's law for E, Gauss's law for B, Faraday's law, and the Ampere-Maxwell law. The prediction. Together they predict waves of E and B moving at exactly the speed of light. Now look at the picture. The electromagnetic spectrum. One family, radio, microwave, infrared, visible, ultraviolet, X-rays, and gamma rays. All of them are electromagnetic waves. Same speed. All of them travel at c in vacuum. They differ only in their frequency and wavelength. The trade. Frequency rises to the right and wavelength falls, and c equals f lambda ties the two together. Energy grows. Higher frequency means higher energy photons, and so the gamma rays carry the most energy. Now, the spectrum at work. Radio waves, used in broadcasting and in television. Microwaves, used in radar and in microwave ovens. Infrared, used in heat sensing, in remote controls, and in night vision. Ultraviolet and X-rays, used in sterilization and in the medical imaging of bone. Gamma rays, used in cancer treatment and in probing the atomic nucleus. Now the formulas that earn marks. The speed. C equals 1 over the root of mu naught epsilon naught, and also C equals f lambda. The fields. E naught equals C times B naught, and the energy density is shared equally between E and B. D intensity. It is the average energy flow per unit area carried by the wave. Now match each formula to its meaning. C equals 1 over the root of mu naught epsilon. Naught goes to the speed of light. Epsilon naught times d phi by dt goes to the displacement current. E naught equals C times B. Naught goes to the field amplitude ratio. And E perpendicular to B, perpendicular to C, goes to the transverse nature. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. Electromagnetic waves are longitudinal. Wrong, they are transverse. Statement 2. In vacuum, all electromagnetic waves travel at the same speed, c. Correct. Statement 3. The field amplitudes obey E naught equals C times B naught. Correct. So the answer, 2 are correct. Statements 2 and 3. The trap is the longitudinal claim in statement 1. Now the 2 mistakes that quietly cost marks. The truth, electromagnetic waves are transverse. E perpendicular to B perpendicular to C, and E and B are in phase. The trap, thinking these waves need a medium, they travel through vacuum. The second truth, the displacement current comes from a changing electric flux, not from moving charge. The second trap, writing E naught equals B naught over C. It is E naught equals C times B naught, so the electric amplitude is the larger. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. The speed of electromagnetic waves in vacuum. C equals 1 over the root of mu naught epsilon naught. Question 2. Are they transverse or longitudinal? Transverse. Question 3. The ratio of the field amplitudes. E naught equals C times B naught. Question 4. The displacement current. Epsilon naught times d phi E by dt. And question 5. The highest frequency electromagnetic waves. Gamma rays. Let us gather it all in one breath. The displacement current completed Ampere's law. Epsilon naught times d phi E by dt. Maxwell's 4 equations predict electromagnetic waves. These waves are transverse, E perpendicular to B perpendicular to C, and in phase. The speed c equals 1 over the root of mu naught epsilon naught, about 3 times 10 to the 8 meters per second, and E naught equals C times B naught. One spectrum, from radio to gamma, the same speed c, differing only in frequency and wavelength. Next class, ray optics, reflection, refraction, and lenses. One missing term, the displacement current, and Maxwell's equations reveal the deepest unity in physics. Electricity and magnetism are 2 faces of a single wave, and that wave is light. Hold the transverse picture, E perpendicular to B perpendicular to C, the speed 1 over the root of mu naught epsilon naught, and the one great spectrum from radio to gamma. Next class, we follow light as rays, reflection, refraction, and lenses. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.